Hello, PreCalc. We are having our evaluation tomorrow in that we are having an exercise where we will look at sum and difference IDs, and we will look at double angles. We will look at power reducing, we'll look at half angle work, and we had an exercise today where we were reviewing problems that use those skills. So, in tomorrow's evaluation, I'm not allowed to say the T word, so I don't bring too much anxiety. We had these 5 challenges today in class, and I'm not sure if I was able to get to each of you to see if you were able to accomplish them, so I wanted to give you the answers. Here's what the problems were. We had cosine of 7 pi over 8, tangent of 165, this equation to solve. We were supposed to use power reducing skills to remove any powers greater than 1. And we were going to find the cosine of 7 pi over 12. Alright, these are good review problems along with the last 2 review videos. They tell you the type of problems to expect on tomorrow's evaluation. Alright, here's how we do the first one, and that was the cosine of 7 pi over 8. The cosine of 7 pi over 8 will make use of the formula here, where I have listed here the formulas. This one, since we're using cosine, we'll zero in right here. And you can see I rewrote 7 pi over 8 as 7 pi over 8 doubled divided by 2. So when you double 7 pi over 8, you multiply it by 2 over 1, which is 7 pi over 4. When I multiply by 7 pi over 8, this is what happened previously. It equals 14 pi over 8, which reduces to 7 pi over 4. That's where this came from. Alright, and when you take that and divide it by 2, it is equivalent to that. So we're using this form because this is not on the unit circle, this is. So here we go. Plug it in, plug it in. When you get to here, give this the common denominator in the numerator of 2. It becomes 2 over 2, which I write 2 plus square root of 2 over the common 2. And then I already divided the 2 by 2. What I say, this is 2 over 2 and over 2, which ends up being 2 plus square root of 2 over 4. Then I have to decide whether it's a plus or a minus, since when 7 pi over 8, that's in the second quadrant where cosine is negative. So that's why I chose the negative sign. Alright, so hopefully that answer makes sense to you. Alright, let's look at the next one. Tangent of 165. I'm going to use the same skill. I'm going to double that and write 165 as 330 divided by 2. This is not on the unit circle. This is. It is a tangent, so the formula is right here. So I'm going to put in 1 minus the cosine of 330 divided by sine of 330. And doing that right here, I get these values. You'll have to write out the portion of the unit circle that helps you get that number. So on the test, I wouldn't take the time to draw the whole unit circle, but like for example on this one I need 330. So 330 is right there. So this, I know I go over the long and down the short. So that tells me that the cosine of 330 right there is the first coordinate, square root of 3 over 2. So that's where I got that value. Then the sine of 330 is second value. That's where I got that. So you'll have to pull that out of thin air, which you have been used to doing. Here is the rest of the work. Notice this 1/2. When you flip that and multiply, these disappear. This negative sign affects both of these terms. And this is the final answer. All right, third one. This is where we have to use double angle IDs to solve a trig equation. Here is the double angle. I'm going to replace it with its value. Sine of 2x is 2 sine x cosine x. Now I just solve by factoring, pulling out what's common, and setting each branch equal to 0. When I find those branches and those values, I see that the pi over 2 and the 3 pi over 2 are exactly a half a circle away from one another. So I combine them and I say pi over 2 plus pi n, half a circle n times. This branch led to 3 pi over 2. We already caught that over here. All right. Fourth one was a power reducing one. The formulas are tucked down here. So I replace both of those expressions in this problem. I notice the top times the top are conjugate pairs. So the middle terms, that's 4 multiplications, of which I'm only going to do 2 because I know the inner and outer products will cancel out. That always happens with conjugate pairs. So 1 times 1, and this times that is negative cosine squared of 2x. Bottom times bottom, we have an evil duck. So I'm going to replace again, and this time in the circle, I've replaced this equation. Now I pull out my algebra, give this a value of 2 over 2 to match this. Then I get 2 minus 1 minus cosine of 4x. That's what all this becomes when I write that as 2 over 2. And then I have it over the common 2. These two are the common 2 divided by 4, which algebraically when I combine those, it becomes 8. The 2 minus 1 becomes 1, and the 2 divided by 4, flip and multiply, you'll see it is 8. Simplified, no evil ducks. And the last one, we had to use sum and difference IDs to find the cosine of 7 pi over 12, recognizing that if you add 1/4 of a pi and 1/3 of a pi, you get 7 pi over 12. So we'll use this trig ID. Plugging it in, I get these values from my unit circle in my mind. Multiply and combine like terms. Well, there were no like terms, but combine over the common denominator. So there you have it. You should, if you are competent in these last couple review videos, there's been 5 on each for a total of 15 problems. Those are the type that you will expect to see tomorrow. There'll probably be 10 problems. So practice so that you can get quick enough to complete the test in the time that we have. All right. Oops, I said the T word, the evaluation that we have. All right. Have a good rest of your evening, and I will see you on evaluation day. Till then, good night.